Let's look at homework problem 1352. I think it's the first problem in the normal and tangential component, binormal component section. We have a girl having a mass of 15 kilograms, and she's sitting on this horizontal disc or platform at a distance, so her center of mass, if you wanted to represent her with a puck or a mass or something, we could. Her distance is 5 meters from the center. The angular motion of the platform is slowly increased, so theta dot is increased such that we can neglect it. It's slowly increased so that the tangential component of acceleration can be neglected. And they want us to find the maximum speed that the girl can travel in the tangent direction before she slips off the platform. The coefficient of static friction between the girl and the platform is 0.2. Okay, first off, free body diagram. In this case, we have some normal direction. Tangent to that path, and at a 90-degree angle would be the tangential direction. And perpendicular from those is the binormal direction. Oh, don't need arrows. Forces need arrows. Okay, we have mg pointed down. She has mass, so therefore she has weight. And we're also going to have some normal force pointed up. Now, if you think about what's keeping her on as she sits, well, as it's motionless, nothing's trying to throw her off. All of her weight is pointed straight down. But eventually, she's gonna want to get thrown off tangent to the path at some point, and we want to find out what the speed is required before that happens, or what the speed we can get to before that happens. But we're relying on this frictional force pointed back towards the center of the circle to keep our butt from sliding us off. We don't have any forces in the tangential direction. They told us the acceleration was negligible. So theta dot is negligible. Okay, let's start Newton's second law on this thing. Summation of the forces is equal to mass times acceleration, and then we can do different directions. Let's try the binormal direction. That is going to equal 0. I just have a normal force and mg pointed down. It's going to equal 147, sorry, that's going to equal 0, and our normal force can be calculated to be 147.15 newtons. We're working with friction, so probably going to need the normal force. That's good info. Let's sum the forces in the normal direction. It's going to be mass times the acceleration in the normal, and we can replace an with v squared over rho, or the radius in this case. That gives me, if we remember that the force of friction is equal to mu times the normal force. We know mu is 0.2. And that force of friction is pointed towards the center of the circle, so it's positive. It's the only force we have in that direction, so that's going to equal the mass times v squared over r. Okay, we know what this is. We just calculated it. We know r, we know the mass. We can find the speed. It comes out to be 3.13 meters per second.